Okay, now we're going to be going through the forces on a cart. This is going to be number 29 as far as your DCA. And they're going to be asking about the frictional force. We can apply this several different ways on this. You do have an angle here as far as your forces here. So we could kind of even mention that. If you're doing the AP exam, they'd be kind of impressed because you're also kind of taking into account this part here. First of all, the main thing is, we are acting on the forces, and we know the first one that's going to keep them from floating into outer space is going to be your gravitational force. And you can put that as a G because that's going to be your acceleration due to gravity. Now, when you're drawing your arrows, this is going to be your normal force because it's going to keep it from sinking into the ground. We also have other forces. Now, it says that you are moving at a constant speed. So basically, if you're moving at a constant speed, you can look at this as being your static friction force and your kinetic friction force. So this is going to be your friction, and that's going to be your kinetic one. And then this one is going to be a smaller force because you're moving, and that's going to be my static frictional force. So now I got two sets of ones that are acting on it. And we also have an applied force, which is actually going to be here. So I'm going to go applied force. And with this one, you could say lower due to angle. From horizontal to inclined. Because if he pulls straight, he's actually going to have more applied force on it. So if you are doing your vector arrows, so here are my vectors, you're going to do it based on the general forces that are acting on this. So you can put in your arrows, and they got to be pointing in the correct direction. So I'm just trying to remember how we're going to do this as far as a vector arrow thing. But your forces are going to be actually pointing in the same direction. Your longer lines are going to be the ones that are going to be the larger applied forces. These are going to be pretty much the same, and this one's going to be a little larger than this one. So let's go vector arrows, let's go here, and then we could go friction static. And then what's my other vector arrow going to be? That's going to be my applied force. We could also mention it as a tensional force. We also have my kinetic friction, so let's move this up a little bit for my applied force so we can account for my angle. And that's going to be a little larger than your static force because you have to pull a little bit harder. My kinetic friction is going to be here, and it's probably not going to be as large as the applied force. So let's adjust our little ones here. Let's go with that, and that's going to be my kinetic force. And then you notice they're all sticking in the same direction, but again, you kind of have to plan out your things here. So this one is actually going to be a little different because I'm going to have to you know, put these as far as what direction they're going. This is going to be my force normal. I would say this one should be friction. And when you're writing these out, try to be a little specific. Force normal, they'll know what it is. And then what would be my last one? Well, my gravitational force, I'll just put G, would be the same magnitude as this one. When you're doing force or vectors, you do have to put them in relation to the magnitude of the force and the friction things. So when they're looking at this, they're looking for these two guys to be the same way. They're looking for the applied force to be the larger of all of them. They're looking for the static force to be the least because you are moving. And they're going to look at your kinetic friction as being higher because you're overcoming your static friction. So if you notice, it's a little more detailed than what probably all of you guys did on this. But again, you got to kind of keep in remember that the forces are based on movement and everything. So you just have to continue to think about all these